Hello everyone and welcome to this lesson in our algorithms and problem solving course. I'm really happy you're here and I'm excited to start this journey with you. In this course, we're not just going to learn how to write code, we're going to learn how to think like programmers and software engineers. Because programming doesn't start with writing code. Programming starts with thinking. A lot of people think that programming means learning a language like C++ or Java, but that's not really true. Those are just programming languages. Programming itself is much bigger than that. Let me give you an example. Imagine someone learns how to drive a car. If they learn to drive using a Toyota, does that mean they have to learn everything again to drive another car like Mercedes or BMW? Of course not, because driving is still the same. There is a steering wheel, there is gas pedal, there is a brake pedal, and there are traffic rules. Some buttons may be in different places, and each car may look different, but the way you think while driving is exactly the same. Programming works in the same way. C++, Python, Java, and C Sharp, there are different languages, just like different car brands. But the way programmers think doesn't change. Once you learn how to analyze a problem and build a solution, learning a new programming language becomes much easier. That's why in this course, we're going to focus on building a strong foundation. Because if your foundation is strong, learning any programming language in the future will be much easier. Now let's answer an important question. What is programming? Programming is simply the process of giving instructions to a computer to solve a problem or perform a specific task. But here's another question. Why can't we just talk to a computer the same way we talk to another person? The answer is simple. A computer doesn't think. It doesn't understand the human language the way we do. It can't guess what we mean. It only does exactly what we tell it to do. If our instructions are incomplete, it will only follow the incomplete instructions. If our instructions are wrong, it will produce the wrong result. And if we don't give it any instructions at all, it won't do anything. So we need a clear and organized way to communicate with the computer. And this is where algorithms come in. An algorithm is simply a set of clear, ordered steps used to solve a problem or complete a task. You can think of an algorithm as a plane. Before writing any code, programmers first create a plane for solving the problem. It's important to understand that an algorithm is not code and it's not a programming language. It's simply the logic behind the solution. Let's look at another example. Imagine you want to teach someone how to drive a car. You wouldn't just say drive the car. Instead, you would explain the steps. Sit in the driver's seat, fasten your seatbelt, start the engine, press the brake pedal, shift into drive, slowly release the brake, press the gas pedal. Now the car starts moving. Notice what we did. We broke one big task into small, clear steps. That's exactly what an algorithm is. The computer works the same way. It needs every step to be clear and in the correct order. That's why programmers never start by writing code. They start by thinking. They ask themselves questions like, what is the problem? What do I want the program to do? What information do I need? What result do I accept? And what steps should I follow to reach that result? Once those steps are clear, writing the code becomes much easier. The code is simply a translation of the algorithm into a programming language. So every program starts with three simple stages. First, understand the problem. Second, design the algorithm. Third, translate the algorithm into code. And that's exactly what we're going to learn throughout this course. Now let's solve our first simple problem. But remember, we're not writing any code yet. We're only learning how programmers think. Here's the problem. It's very simple. We want to create a program that prints a name on the screen. So let's analyze it. What is the problem? We want to display a name. Now let's write the algorithm. Step 1, start. Step 2, print Lina. Step 3, end. That's it. Notice that we didn't write a single line of code. We simply described the steps needed to solve the problem. And that's exactly what an algorithm is. Now it's your turn. Your homework is, instead of printing a fixed name, I want you to solve this problem. Create an algorithm for a program that asks the user to enter their name and then prints it into the screen. Don't write any code. Just answer these four questions. What is the problem? What are the inputs? And what are the outputs? And finally, write the algorithm step by step. Write your answer in the comments and I'll be happy to read your solutions. In the next lesson, we'll take this algorithm and learn how to represent it using a flowchart before we start writing code. Thank you so much for watching and I'll see you in the next lesson. Anytime, good smart, not hard.